All right, class, good morning. So obviously I'm Mr. Nerva. All right, so today we're gonna be going over weathering and erosion. I'm gonna say this is my first video and I'm probably gonna make a lot of mistakes, and I'm probably gonna also try this all in one take. So forgive me for my mistakes, when I say things wrong, but let's go with it. All right, so let's get into this. So this will be a pretty short video. It's on two main concepts I want you to understand for this week. You've probably heard of them before. We're gonna add weathering because erosion basically is something that everyone kind of conceptually knows is when stuff gets broken down, but broken down and carried away. So like sand, for example, on the beach, that's all from erosion, like eroded rock. But in any case, let's start with weathering, because before you can have erosion happen, you need weathering. So weathering is basically when the parent material, whether that's some kind of rock, there, of course, as we've learned, many kinds of different rocks, whether metamorphic or igneous or sedimentary. We have weathering is basically the process of taking that parent material or the whatever rock type that is and breaking it down into smaller pieces. Now, the smaller pieces could be things like large as boulders, like something that weighs 2,000 pounds or more, or it could be even smaller pieces like, could be even the dust that's on sand, right? So very extremely small particles or pieces. So, but this process isn't always the same. So they get broken down three main ways. You have mechanical. I've drawn a little image of two gears moving together, because basically what mechanical means is that there's some kind of physical contact or movement between two or more things. So that could be, for example, when we talked about glaciers, right? These gigantic sheets of ice that are sliding and moving on the ground. Think about how the process, what's happening as the glacier is sliding, right? The glacier is almost unimaginably heavy, right? And as it's sliding along one large heavy solid on another heavy solid on the rock, sliding, that grinding that's happening at the interface, or where those two things are touching, that's interface means. So at where those two things are touching, you have a mechanical process, two things touching and moving and grinding or sliding with all that friction. That's going to cause the grinding down of not only the glacier, but the rock as well. So mechanical is any kind of movement, physical touch that's going to result in breaking down into smaller pieces, however large or small those pieces are. The next is going to be chemical. Chemical processes, that the most familiar one is going to be I wrote acid on this Erlenmeyer flask containing this unknown liquid, but I'm just saying it's an acid. So an acid, as you know, is corrosive. It's going to eat away larger pieces of material, such as rock. If you get a piece of limestone or marble, and you take even some vinegar, some acetic acid, and you drop it, you should notice that it's going to bubble. There's a chemical reaction going on there where the acid is chemically reacting or changing the molecular makeup of that rock. And as the acid eats away at the surface of a piece of limestone, or even a shell, right, like a shell that you find at the beach, those acids would eat it away and break up the shell or rock into smaller, tinier pieces that can then be carried away, right? And then next and lastly is the biological mechanisms. It can kind of be a combination of these two things. So as we've been kind of seeing in our class so far this year, is that there's a lot of carryover, overlap, connections among these things. So all three of these things can be happening at the same time. So for example, if you've ever seen plants growing up in between the cracks in concrete on the sidewalk, and you can see that those, or if you've ever been walking on a sidewalk, especially if you skateboard or do anything like physical like that, you end up seeing that sometimes the sidewalk is not flat. It's maybe like even raised up and cracked in a lot of different places. And that's the result, okay, of roots, right? Plant structures growing underneath the concrete, and as they grow, they put pressure, okay, physical pressure, mechanical pressure on that rock and causing it to break over time. Also certain, not all plants, but some plants actually excrete chemicals enzymes that actually eat up and break down the rocks over time to create soil. So you have these three main parts of weathering. So when you say weathering, and I mean it's spelled the same way if you cover up the ing, weather is like the weather outside. However, in this sense, we mean weathering as in breaking something down over time. All right. So the first process is always going to be weathering. Okay. After weathering, then you get the process known as erosion. So remember, all erosion is after the weathering process has happened. Now those small pieces, right, that were broken down, they get physically moved to another part of the planet, right? And two main ones that I want to talk about are wind and water. So what wind does is, and notice that it lets us do some kind of fluid, something that can change shape and move over a large scale. So wind, for example, is moving air, and as that air moves, it can pick up, carry, blow away, and move something down a hill or a mountain, right? As this rock, for example, that I've drawn is broken down, its small pieces eventually can get blown away by the wind, right? This just flows or rolls downhill, and part of what we used to be this rock. Sorry, I have automatic lights, so let me get this. All right, so this rock that I've drawn here, as the parts of this rock that used to be part of it have been broken down, get physically moved away. So over time, you would probably guess that this rock would get smaller and smaller and smaller. In fact, we have seen there's scientific evidence and data that shows that some really, really old mountains used to be, hills that look like hills now used to be much, much taller and much, much larger. Those are the older mountains, the ones that have been smoothed over, that have been weathered away and eroded, right? That rock has been moved over millions of years to other places, right? So, and then also similarly, as things like sometimes there's acid in rain from pollution that's reacting with the water in the clouds, after condensation, you get that sulfuric acid created. And as that falls down, that can aid or help in breaking down the rock. And then as gravity pulls the water down, as the water flows down with gravity, it also pulls some of that sediment, the particles that have been broken down over time through weathering, and carry them down into rivers, lakes, streams, and back into the oceans, right? Carrying down nutrients that come from those rocks, like phosphorus, for example, that eventually go and are used for living things. All right, so okay, so basically just a quick review. We have larger things in the environment on Earth are broken down, so the crust is weathered over time. It's part of why we can't see meteor craters, for example, because craters over millions of years get broken down over time, and parts of them that used to make great mountain ranges from those craters get broken down over time, mechanically, chemically, biologically, and then those small pieces from those three processes get carried away to another part of our planet. All right, so that's weathering and erosion. I'm also going to post a presentation that kind of gives you a little bit more information on probably more than I've even talked about, but you can learn a little bit more deeply. Take your time and read about some more examples about weathering and erosion. All right, thanks for listening, and email me, go to my office hours, and all right, hope you're all doing well and staying healthy, and have a great day.